Hello everybody, welcome to another legit coding exercise. Today we are going to be demonstrating classes for the AP exam. So on the AP exam, they like to ask questions about derived classes from a superclass. They want to know how can you pass information back and forth between constructors for the derived class to the superclass, and how can you call functions or methods from the derived class that override methods from the superclass. So let's take a look at that. I don't have the actual question in front of me, but there's a question where they ask about supers and methods. So let's look at classes. And to start, I'm going to grab my blank Java file, as always, drag it over into my source, and it says, do you want to copy it? I want to copy it. I'm going to rename this thing before I start typing it. So where'd my blank go? Here's my blank. I'm going to open it up. So I'm ready to edit the blank. I want to change its name. So I'm going to right-click in Eclipse, choose Refactor in Eclipse, choose Rename. So I'm renaming this file. Again, in Eclipse, the file name must match the class name. So this is going to be a ClassDemo class. Okay. So now I have my ClassDemo. It says ClassDemo at the tab. And we're going to write comments for what we want to do here. And so in this file called ClassDemo, we want to demonstrate general class concepts. And so we have encapsulation. And encapsulation means combining or grouping methods and variables together. So a class is just a box or container, and in this box or container, where did I go? Here we go. We're just putting methods and variables together that belong together, such as a shoe might have a number of strings on it, so shoelaces.
Good morning, Pirate. Just a reminder.
So encapsulation, again, groups related things together. And then with encapsulation, we have another concept which is called, let's see, it's encapsulation, concept with the object, abstraction. So these are two concepts with objects. Abstraction means you have a public interface, where an object or a class does stuff, and all you need to know is how to use it. And that's what abstraction is. It's the public interface or the public methods of the class. So what things do you need to know? You need to know how to make a class. What's it called? You are declaring classes. You need to know how to instantiate objects. A class has constructors. Class has instance variables. Class has methods. A class may have static variables. A class may have static methods. See what's left. Class has ordinary methods. Oh, I have them. And a class may have a superclass. A derive. One and only one superclass. And a class may, this is called, I'm sorry, let's use the Java terms. It extends from one and only one superclass, and it may implement one or more interfaces. And I think that's it. So let's start our classes. And this is our demo, so we're going to make a main here. So let's do our class first. ClassDemo. And here we're going to have a main. We're going to use our main to test our classes. So we have a static, public static, main, or void main, sorry, void main, and we have our string array args. And here we're going to test classes. So let's make a simple class first. Simple class to demo instantiation, declaring instances, methods, static vars, static methods, and constructors. Okay, so our simple class. What do you want to make? What kind of class? Any ideas? Apples? I don't know. Sure. Sure. So we're going to model apples using a class. And to do that, we're going to create another file which has the class in it. So let's create another file. I'm going to grab my blank file, move it over again, and rename the blank file. And we're going to call this apple. So refactor it, rename it, and let's call this the Apple class demo. Let's just call it Apple. Make it simple. Apple. So this is the Apple class, and its job is to demonstrate simple class mechanics and syntax. And so we need a public class Apple. Has stuff in it. So if this is how we declare class, use the word class, use class, and then a class name. Do notice that convention, the class name is camel case with a leading capital letter. And by Eclipse standards, the name of the class must match the name of the file. So now I have an Apple class. If we make an Apple class with nothing in it, defaults to a what's called a default constructor. So constructors initialize the class variables when the class is instantiated. And right now this Apple class has nothing in it. But we should still be able to make one and print it out. So let's do that. We're going to make an Apple class. Apple, my Apple. We'll call it my Apple A. This creates the reference variable and has null in it. And then to create something, we use my Apple A, which is the name of the reference variable, equals new Apple, and Apple as a default constructor. And then we print it. System.out.println my Apple. Now this should run if I spell this like system.out.println my Apple. What's wrong with it? My Apple A. My Apple doesn't exist. Right. If we run this, we should see just the garbage from the default toString, and we do. We made an instance of the class Apple, and this is the hash code for it. But that doesn't tell us anything about what's in an apple. So all classes should have a toString. Let's add that in the instructions here. Declaring instant blah blah methods, static blah 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 blah. May implement one more interfaces, and we have the object class. Class is super of everything, and the object has a toString, which returns a string. So every class has a toString because they do inherit from the object class. Any class that you make, such as the Apple class, inherits from the object class without you having to do it. The object class has a toString, so here, when we're printing my Apple, we're actually calling my Apple.toString. So let's put a period at the end of my Apple, and lo and behold, we see what an object has, and one of them is the toString. So what happens when you try to print my Apple is it converts it to a toString by calling toString method. And when we run this, we see the same thing we saw before is the hash code. So next thing to do is to give the Apple class itself a toString. toString. This is an override. I think it's at override. Let's see if I can get this to work. Is it control space? There we go. And this is a public to string. I'm sorry, string to string. I'm just going to say something here. Return an apple. So now when we run it, we see that instead of calling objects toString, it reverts to calling the apples toString. We can call the objects toString by doing super.toString, and we'll concatenate this to a return string. So we make a string, ret string equals the blank string, and then we add to it ret string plus equals super toString, and then we do ret string string plus equals an apple, and we remove an apple, return the ret string, and we run it, see what happens. Here I'm just playing with the return string, and I'm playing with the constructor for super. So let's put a space in front of an apple. Run it again. If you look at the output here, we've called the super. Remember, all classes extend the object class. And so that means all classes have a toString. Here we're overriding that object class's toString. So we're making our own toString for the apple. And instead of calling the object class's toString, it's going to call the apple's toString. We make a return string that's empty. We add super's toString to it, and then we add our and apple to it. So we see the super toString here, and then we see the apple toString here. And this is an example of overriding a method. What overriding means, instead of using the base class's method, objects toString, which returns this thing here, we instead use apple's toString, which returns these things here. All right, what's next? We look at a class. Its purpose is to combine methods and variables together that exist. So we have this apple. Can someone tell me what kind of characteristics an apple has?
It has a stem.
Has a stem, okay. It's red, so we have a color. Unless it's green, so we have a string color. And we have an int, let's call it stem size. And this is an example of variables that we're giving to the apple. What about things we can do to the apple? We can eat it, reduce it by eating. We can reduce the apple. Cut it, okay. We can burn it, okay. So what does reducing the apple do? Blend it. Juicing, okay, we can juice it. So these are different ideas of what to do with the apple. What can an apple do?
It can give us energy.
Okay. It can give us energy. Reduce, cut, burn. Burn kind of gives energy. We can get juice out of it. We can cut it. We can reduce it. Cutting and reducing are kind of the same thing. So let's use cut. Okay. We can throw it hard so it moves. Moves. Does damage to people's heads.
Shoot arrow into it. Maybe.
Okay.
Maybe.
You can hit it with an arrow. So let's look at one of these. Let's look at cutting the. Let's look at burning the apple first. So if these are all examples of methods. And a method is something. What can you do with an apple? So the burn method. What does the burn method actually do?
Like digestive burning?
I don't know. Let's like calorimetric burning. So you put in a calorimeter and you burn it up and you see how many calories are in it. So we're just going to. So let's have burn find the calories in an apple, and at the same time reduce the apple to ash. So it goes away. So this says that the apple might have some kind of weight. Should we add a weight to the apple? Why not? All right, so we have an apple's weight, and we burn the apple. We can figure out how many calories the apple has. Why am I writing it as a float? Weight? Why did I write float instead of int? I can make stem size a float too. That'd be better. There we go. What does float do? Yikes. Okay. All right. So there are types of simple variables. Int and ln hold, yes, exactly, hold integral numbers, such as 0 or 1 or 2 or -7. And floats or doubles hold floating point numbers, such as 0.125 or 10 or 1.957 e to the -14.
So why is it float instead of double?
Doubles make it bigger. You want to do doubles? So we can be super accurate on stem size and super accurate on weight. We can do that. It's better than floats. We got lots of space here in the computer. All right, so let's look at this burn again. We're going to burn the apple. It gives energy, finds the calories in the apple, and reduces the apple to ash. So we do two things, right? Find the calories, reduce the apple to ash. So let's write our function. It returns the energy in the apple. So the energy, what kind of units should the energy come in?
Joules.
Joules, which is a floating point or a double, right? And the name of this function is burn. And do we take a parameter here, or do we burn all the apple up? Or what's left of the apple? We burn what's left of the apple up, yes?
Yes.
Okay, so burn takes no parameters, can burn the remainder of the apple up, reduces the remaining apple to ash, and then returns the calories. So we need to find the calories. It's going to be a double. Calories. And calories is going to be equal to weight times some kind of burn factor. And this is really calories per, I don't know, ounce. So now we know how many calories there are, and then we reduce the weight to ash, right? Weight equals 0.0, and then we return the calories. Now our problem is we have this burn factor. So let's look up apples and see what their burn factor is. I forget what it's called, but we could look it up. Calories in an apple. And we want to know what's the 95 calories. How heavy is this apple? There's one medium, 182 grams. So it's 182 grams gives 95 calories. So let's do that. We're going to write that. It's 95 cal in 182 grams. So let's do weight in grams. That makes it easy. And an apple, a medium apple, is 182 grams. All right, so far so good? So we now have a burn factor, which we can stick in here. So we're going to make a static up here. We're going to make a static final double burn factor. Let's make it big. Burn factor. Put an underscore between the two. And this burn factor is going to be 95,000 kcals per 182 grams. Kcals. So calories, if you look them up, are really kcals. Do we want to return kcals or calories? Let's just stay the same round. We're going to do 95 here. We're going to stay in kcals. Everyone uses them, calls them calories with a capital C. So we're going to return calories. We put a C here. Capital C is really kcals in an apple. And we have the conversion factors called burn factor. So instead of burn factor, we can use this. And that'll give us the actual calories in our apple. We burn it up, and weight is in grams. So we say weight in grams. And we're good. All right, so now we have the apple can do something. The apple has some sizes, and we needed some way to set the sizes. So let's set the size for the default constructor for the apple. And let's do constructors right here after what variables have. So constructors initialize the variables of an object, in this case it's an apple, when the new object is instantiated. And we need a default constructor. So constructors, syntax, is just the name of the object, or class name, and followed by a parameter list, and then statements. So let's do this here. The name of this thing is Apple. We want this constructor to be public. This is the default constructor, so it has no parameters. And in the default constructor, we want to set the color. Color equals red. Oopsie. You want red apples to be the default? Stem size. 6 in, let's do millimeters. Let's do centimeters.
Centimeters?
Sure.
1 times 10 to the 8.
1 times 10 to the 8 centimeters. Holy moly, that's a huge stem. That's the whole tree. That's more than the tree. 10 to the 8. So a meter is 100 centimeters. So that knocks 2 zeros. So this is 10 to the 6 meters. So we're looking at 100,000 meters, which is, let's see, a mile is, a meter is about 3 feet. 5,280 divided by 3 is about 1260. So it is about 60, 70 miles tall, which is higher than Everest. So that's too big. So how big is a standard centimeters? 2? 1? 1.0.
It's in millimeters.
You want to do it millimeters? Millimeters.
Like, what about 5 millimeters?
5 millimeters?
5.
We can't do it 5 feet.
We can do 5 foot, a 5 foot stem.
6'6".
6'6"?
Yeah.
All right, so let's do 66. Let's make these centimeters, because I like centimeters. So let's make this 6.6 centimeters, which is a huge stem. So this is about 3 inches, which is generally a very large stem for an apple. And the last thing to do is the weight. Let's make this a standard weight apple, medium apple. If I can spell weight, HT, there we go. WIGHT, and this is going to be 182.0 grams. So color, centimeters, and grams. So now we have a brand new apple. And let's change the toString to print our apple. So instead of printing the super, we're going to get rid of the super. Goodbye, super. And apple. So let's say what kind of apple. And plus color. Apple. And we need the weight and stem. Weight plus weight plus stem plus stem. Oh, we got an error. Unresolved come from blah blah blah. Apple toString.
Why does it say it doesn't work?
Why I did something wrong up here? Let's see. And plus color plus apple plus weight. Did I spell weight wrong? WEIGHT. Oh, stem size. Aha, there we go. That's why it's wrong. Because it doesn't know what the stem is. What's the stem? I don't know what a stem is. Because you didn't tell me what a stem is. Oopsie. Did the wrong thing. Stem size. All right, here we go again. Let's try it again. Now we see an apple, a red apple, 182 grams and 6.6 centimeters. Let's put grams and centimeters in there. So let's see, W, grams, and stem size, centimeters. All right, here we go. Much better. So now we can make apples. So You can do GM or G, yeah. I forget. Doctors might do GM. Oh, whoopsie, wrong place. Yeah, grams are just G. So now we have an apple. We see that we have attributes of the apple. We see that we can use a constructor to set the apple's attributes. Ideally, attributes are private. So right now, we're making an apple and we're printing it. But what we can do with this apple, my apple A, is we can get the goodies out. We can get the color and change it to something crazy. Right? Clear? Yeah, we can make clear apples. And here, when we print it again, we see that we can use the member directly to change the color of the apple, something crazy apple. A lot of times you don't want to do this in encapsulate because maybe you have specific colors for an apple. Red, green, yellow, pink, and you don't want any other colors. So you don't want purple or, I don't know, blue polka dotted apple. To prevent, yeah, blue polka dotted apple. Right now, okay, right now the color of the apple is not specified protection. To protect the apple color, we can make it private. Protect the stem size, we can make it private. Protect the weight, we can make it private. So one of the things we should know is we can start with an apple weight, but we can never really make the apple bigger. Once you pull it off the tree, it's not going to get bigger. It's going to get smaller, right? Not bigger. So we want to protect these from users to make fake apples. We want our apples to be real apples, not fake apples. And to protect our apples from stupid users, we're going to make our attributes private. And this means that the user cannot change them directly. So once I've made color private, if we go back to ClassDemo, I'm going to save everything. We see we have an error here. An error says, field apple color is not visible. And the quick fix is change the visibility of color to package. We don't want to do that. Create getter and setter for color. So that's what we want to do. So once the apple has a private attribute or member, that member may no longer be accessed from a non-apple function. So main belongs to ClassDemo. Main is not an apple function. So main may not access color directly because color is private and only the apple may access color. The fix is the second guess here. It says create a getter and a setter for color. So we click on create a getter and a setter. And it says getter name get color, setter name get color, blah, which sounds good. Use setter and getter and keep field references is fine. We can generate method comments too, and we say OK here. Nothing changes in main. If we go back to apple, we now have some magic getters and setters. They should be at the bottom. Here they are, get color and set color. Notice they are public. Can main use these?
Yes.
Yes, it can. And here's our set, right? So we want to make sure color is the valid color. So maybe we check it versus a list of valid colors. If it is a valid color, we set it. So right now, let's make sure it's red. So we're going to do if color dot compare to red is true. That means we do have red. Then we're going to access it. If it's not, we're going to set it to a different color. Else this dot color equals let's make it green. So if they try to set an apple that's not red, it's going to make it green. So let's go back to demo. And the user is trying to make something crazy. So now instead of saying color directly, it changed it to set color. Look. And now it's something crazy when we run it. It's a green apple, not a something crazy apple. We protected it, right? We protected our apple from stupid users. And this user is trying to make a crazy apple, but we're not going to let him. We're not going to let him because we made our apple attributes private. See that? Private. That protects them from crazy users. And to protect it, you just have what is called validation conditionals in your setters. And that will protect it. Return color. This is a string. Let's see if we can play with this. Now, a string is a reference variable. And if this is returning color, it's returning the reference to get color. So in our class, let's try to use get color to set the actual color and see what happens. My apple a dot get color equals something crazy. Let's see if this works. Crazy. Okay, there we go. I don't think this is going to work. It's mad at me. It's not going to work. It says the left-hand side assignment must be a variable, and it's mad, so it won't let me do it. Oh well. So it's smart. I thought I could trick it that way, but I can't. This is smart. Okay, good. In C++, if getColor returned a variable, you could use that variable to set the getColor to something else, just like this. Maybe can we do a set? That should overwrite it. Let's try a dot set. Oh, sorry. Do strings have dot sets? Let's see. Substring replace all. Is there a set or a return? Let's see. Set, split, start, substring, replace. Old character, new character sequence. Replaced first. String regex, string replacement. Join, value of copy. Replace, old character, matches, notify, last index of. Get bytes. What I want to do is just replace this. And we had some replacement. Let's see. String regex, string replacement. Let's see how this one works. Replaces the first substring of the string that matches the given regular expression with a given replacement. So let's replace green, or EE of green, with crazy and see what happens. See if it'll do that. Ooh, it might work. And let's do my apple and print it again. So I'm trying to cheat. I'm trying to get around that public and see if this works or not. Dum-de-dum-de-dum. It did not. Okay. So Java's pretty smart and is thwarting my ability to cheat and hack it. Whoopsie. So let's do an undo. Where's my undos? That's what I want. And I wanted to comment these out. Control / There we go, much better. Okay, so we can't use replace off of a get to actually access the string that comes out. So it looks like it's a copy of the string. It's not the string itself, which is what you want. Okay, so we've looked at two things here. We've looked at a simple constructor, the default constructor for the apple. We've looked at a method for the apple. We've looked at toString for the apple, which is overriding a derived method. How much time do I have left? Oh, I'm talking too long, aren't I? And we looked at getters and setters. And we looked at encapsulating the apple. Encapsulate means protect it from super people. And we looked at a static variable. A static variable belongs to the class. So if we go back here to the main, we can actually print the static variable before we have any apples. So right here on line 25, system.out.println, and we can get an apple.burn factor. And we can print the burn factor for an apple, which should be that value, which is what, 0.52 something. This is calories, kcals per gram, I believe. Kcals per gram is the burn factor. So we print it out. So this exists, this burn factor exists in the absence of instances. This is not true for the other things, so we can't do this one. System.out.println apple.getColor. I think it's getColor like that, right? GetColor, or do we have something crazy to replace? I don't have a getColor here. What's our getColor look like? String get capital C color. So I spelled it right. If I do a save, this getColor fails, and it fails because cannot make a static reference to a non-static method getColor. So a static reference, the keyword static, which we have somewhere up here, here's one, means that whatever is after static belongs to the class, not to instances of the class. So we have at the top here, these are instance variables. And the burn factor is a static variable. Now a static variable belongs to the class and every instance. And instance variables belong to one instance. So that means every different apple has a different color, different stem size, and different weight. But every different apple has the same burn factor. It's owned by the class, not by instances. Same thing for methods. The constructor creates a new instance. A burn works off instances. ToString works off instances. GetColor and setColor work off instances. So we don't have any methods right now that don't work off instances. And if it works off an instance, we have something inside called the this keyword. This is a reference to the calling, whoopsie, I can't do it there. This is a reference, Control X, to the calling function. And if we see a blue variable that hasn't been declared in a function, that blue variable is an instance variable. So up here we see we have made weight and it's blue. Local variables are brown variables. Here we made a calorie, it's local to the method, it's brown. Brown variables only exist inside the method. Once the method exits, the brown variable is lost and disappears. Blue variables exist outside the method, and they will last as long as that instance lasts. And then this big black or bold blue variable belongs to the class and exists as long as the class exists, which is forever. The last thing we're going to show is here we're setting the color. Notice we have this color, lowercase c, that's brown. And we have this other color, lowercase c, that's blue. And the only way to tell apart two colors that have the same spelling in the same function is with the this keyword. So this means that this color is blue, which means it's an instance variable. And this does not. This color over here, this brown color, does not have a this, and so it's brown, which means it's local to the method. And this brown color will disappear once the method exits. That's the difference between static, instance, and local variable. All right, we got that? All right, where else were we? So we're trying to make this apple, and what have we done? We've done encapsulation, we've done abstraction, we've done declaring classes, well, we've done instantiating objects. So let's review that one. So in the demo, we instantiate the object with this following syntax here. We create a reference variable, and then we use the new keyword and a constructor to create an instance of the variable. So this creates an instance, and apple instance, and references it with my apple A. So my apple A, the reference variable, does not actually have the apple in it, but it references the apple instance that we created with new. So here we're instantiating an instance. If I can spell it right, can't spell it right, let's get that out of here. And here we're printing it with ToString. Here we're trying to set the color of something crazy and it fails. We're using the setter. We don't have a getter, but you've seen a getter. Let's see what else we're looking for. So we've done encapsulation, we've done abstraction. Encapsulation is grouping methods to variable and using that private keyword. We've done declaring classes, done methods, done static variables, done static methods, done a constructor, enough. May extend from one and only one. Okay. Extensions. We haven't done these steps yet. May implement one or more interfaces. Object class is super of everything. So let us do, we have 10 minutes left. Let's do a super. So to make a super class, we're going to make a super class for the apple. So what kind of thing is an apple? It's a non-vegetable, so that is a fruit. Apple's a fruit, but fruit doesn't exist yet. Oh, that's sad. So if we hover over fruit, it says fruit cannot be resolved. We're going to create a class fruit. This will create a superclass for this, and this is fine. We're going to finish. So now I have a class fruit, and what do you want the class fruit to do? What can a fruit do? so we can eat it, right? It can provide you calories, which is burn. So let's make fruits burn. And burn is the same as the apples burn in syntax. So it's a public double burn. So go to our fruit, and it can public double burn. Now, a fruit class, does generic fruit exist? No. So fruit is going to be a abstract class. And I think, let's say public, I think it's abstract. Where do we put abstract? So I'm trying to remember how to do this. Oh, it's mad at me. What's it say? So syntax error token, delete this token. How about class? Public abstract fruit. Interface expected after this token. Oh, crap. So we have to make it an interface. So, only interface. Let's screw the interface. No, let's make this an interface. So fruit, we can actually make a fruit. So we're going to make it an interface. It's an abstract interface, which means it has abstract functions, and it has this burning thing. So we need to be able to burn. Returns a double. This makes it an interface. Apple is no longer extending from fruit, but it's implementing fruit. And since it implements fruit, our burn becomes an override. And now we have a burn. And that means that in our class demo, instead of making the apple, get color. Why does it matter get color? Can I make a static reference? Oh, because we're mad at that one. So let's fix that. We're instead of making these into apples, we're going to make these a fruit. Now, fruits don't have set colors, but what we can do is we can cast this to an apple, my apple, and then use the set color on that. Alright, so we changed a few things. We made my apple a fruit. We actually made it the apple. So we see that superclasses can point to or refer to instances of their base classes or their derived classes. So a fruit is an apple, but an apple is not a fruit. So here, off of my apple, I tried to use set color, and it didn't work. So without casting my apple as a fruit, is a fruit not an apple, although it really is an apple. It really is an apple. But fruits do not know how to do set color. So my apple a dot set color does not work, but it does work if you cast it to an apple. That's what we're doing here. But what does work off the fruit dot burn is burn. Look, burn works. And burn gets out some calories, so let's see how many calories come out here. System dot out dot print line burned plus my apple dot burn plus calories. Alright, let's run this and see what happens. Do be aware what happens down here on line 41. We're going to burn the apple. What happens to the apple when we burn it? So here we burn the apple. We got 95 calories out of this medium apple. And what's the weight? 0. A green apple. Should it be green anymore? Or should we change the color when we burn it? Let's make it gray. Okay. So we burn the apple. And we get calories out. We set the weight to 0. And now the color is gray. Burned up. We're going to make it ash or something. A gray apple. Let's make it ash. That's even more good. Ash. There we go. Alright. So we burned, now we have an ash apple that doesn't weigh anything. And we still have a stem there. 6.6 centimeters. Okay, so just the stem is left. So here we see how an apple can implement an interface. We can also derive an apple from something else. So let's make a gala apple. A gala, I don't know what the difference between apples and gala apples are. So we're going to make a gala apple. I can go source. The other way to make new files is to use the class. We're going to make a gala apple. The gala apple is going to implement. Going to add an interface here. And we're going to make an apple. So let's see. A-P-P-L-E. Not an interface. We don't want an interface. We want a superclass. Here we go. And the superclass is the apple class. So we're going to make this an apple. There it is. Apple. So now this gala apple is an apple. It inherited abstract methods. We finish it. We say that extends the apple. And well, what is different between a gala apple and an apple? Cost. It has a color. Let's make the gala apple constructor. Gala apple constructor. Public. Super. That calls the super constructor. And we need to set the color. Color equals rose. Let's have the gala apple be the same as rose. But now the gala apple is mad. We want the gala apple constructor to make a gala apple which will make the color of the apple rose. But right now it's not working. And it's not working because the apple's color is private. We can make this protected. If we make the apple's color protected, that means it, the apple, and any derived class has direct access to color. So now the gala apple should be able to set its color to rose, and it can. Notice the color becomes rose. Notice our gala apple doesn't have any colors here, right? Where's the color? And the color is in the superclass apple. So gala apples have everything apples have. They are indeed an apple. We're about to end this thing. So one of the ways to get direct access to the variables is by changing the variable type from private to protected. The other thing we can do is we can add getters and setters to the apple. So let's do, what was the other thing we had? Stem size. So we'll set stem size. And we're going to make this 2.3 centimeters. Well, now it's mad at us, right? It says stem size doesn't work. So we're going to create getters and setters for stem size. They're created in apple. And now, gala apple is calling the apple's stem size, which is public, and passing 2.3 to it. And now the apple has getters and setters for a stem size. So here's get stem size, and they're public, which means anyone can use them. And that's how to give people access to private variables. Also to give derived classes access to protected variables. So now we've talked about some more things. Let's look at our list of what to do. Let's make a gala apple. We can say a fruit equals a gala apple, new gala apple. Oh, I have to name it something. This is my apple B. And that's it. All right, that's all the time we have today.